Now consider elasticity. So what is this elasticity? The inherent property of the body by virtue of which it regains its original shape and size when the external applied force or deforming force is removed. So on any body, if you apply the force, let us say this body is pulled, then the shape of the body and size of the body changes. Once you remove this applied force, if the body regains its original shape and size, then the property with which this body regains its original shape and size is what we call elasticity. So it is defined as the inherent property of the body with which it regains its original shape and size when deforming force is removed. Inherent property. Because of this, it is able to regain its original shape and size when the deforming force is removed. So what is the deforming force? The force which tries to change the shape of the body is called deforming force. Deformation, the change in the distance between the particles or the body molecules present inside the body. So when you apply the force, the distance between them definitely changes. This is what we call deformation. Suppose if the shape of the body changes, then the body is said to be deformed. Suppose even if you apply any amount of force, if there is no change in the shape, then the body is said to be a rigid body. So on a rigid body, if you apply any amount of force, its shape is not going to change. The distance between the particles inside remains the same. But if you take any real body, any body existing in nature, so we'll call it as a real body. All real bodies, when subjected to the force, deforming force, the shape automatically changes. Now, once you apply the force on it, this is the deforming force. If I say, immediately inside the body there develops a force called restoring force. So this is deforming force and this is restoring force. Once the deforming force is removed, restoring force tries to restore the shape of the body. This property is elasticity. Now, basing on this property, bodies are defined as two types: elastic and plastic. When the deforming force is removed, if the body regains its original shape and size, then it is called elastic body. If it is not able to regain, body cannot regain its original shape and size, then it is called plastic body. So in the case of plastic body, you can see the permanent deformation, but elastic body completely regains its original shape and size when the deforming force is removed. So normally, if I take an elastic body, the deforming force and applied for this deforming force, which is nothing but the applied force, is equal to restoring force. If these two are equal, then only once you remove this deforming force, because of the action of the restoring force, body completely regains its original shape. There is no perfect elastic body in nature. Perfect elastic, impossible. Never exist in nature. But for practical purposes, steel, quartz, etc., they are considered to be elastic, because large amount of force is required to produce a deformation. All bodies in nature are plastic bodies only. Perfect elastic body is impossible. Now, here we can define a quantity called stress. So what is this stress? Stress is defined as the restoring force developed per unit area of cross section of the material. Stress is defined as restoring force per unit area of cross section. So this is equal to F by A. Unit of stress is Newton per meter square. So restoring force per unit area of cross section. We know that if the body is elastic, restoring force is equal to the applied force. If I say F is the applied force, I can take F by A as stress. So it is the restoring force developed per unit area of cross section. Here we can define three types of stresses: linear or longitudinal stress, volume or bulk stress, shearing or tangential stress. So these two are basically called normal stresses, and this is tangential stress. So there are total three types of stresses in nature: linear or longitudinal, volume or bulk, shearing or tangential.